Next is, look at this one. Okay, so here fx must be a polynomial. Okay, and the gx must be a polynomial to use that rule, polynomial. If fx has a fractional exponent or negative exponent, this rule does not work. You understand that? If the top function and the bottom function, so this is a polynomial, this must be a polynomial. You understand? So if the top or the bottom function are not polynomial, what do you mean by that? If the exponent are fraction or negative or roots are involved, then you cannot use these rules. You cannot use this rule, because these rules assume that f has a degree, meaning it is a polynomial with certain degree. G has a certain G is a polynomial with certain degree. Then you can use this rule. Now here, look at this. This is not a polynomial. The top one is not a polynomial because the exponent is fraction here, right? So in that case, you will use the second method. You cannot use the first method here, so you can use the second method. What we do, you take the highest exponent out from both top and bottom. Okay, let us do that. On the top, there is no plus term, so it is already taken out, so we don't have to worry that. So limit x tends to infinity 5x to the 3/2 divided by, there is plus in the denominator, right? So you need to take the highest exponent of x out. So I will take x squared out. What is left is 4 plus 1 over x squared. You see that? Now, what do you do next is, now try to cancel out this and that, or you can move this to the top or move that to the bottom. Which one is bigger? Is x to the 3/2, the 3/2 is bigger, or x to the 2 is bigger? 3/2 is 1.5, right? Then the 2 is 2. So you need to move that to the bottom. So what I'm trying to do here is equals to limit x tends to infinity 5 over x to the 2 times x to the negative 3/2. Why did I do that? Is 4 plus 1 over x squared. Why did I do that? Is because I want to combine these two. That's why I'm just keeping that x to the negative 3/2. Now I will combine that into a single x. So let me plug in that x tends to infinity in the second parenthesis. I can do that. So this will become 0, right? Because 1 over infinity will be 0. So what is left is 5 over 4 times that thing. So let me write down that. So this is 5 over 4 times, what is x to the 2 minus 3/2? Because if you combine, it will look like that, x to the 2 minus 3/2, right? 2 is 4/2 minus 3/2, which will be 1/2. That will be x to the 1/2. But what is the limit? Limit is x tends to infinity, right? If you take limit x tends to infinity, you will get 5 over 4 times infinity. It will be 5 over infinity, right? So this is basically 0. So the answer to this question is also 0. Okay, now, so can we use L'Hopital's rule? Because when you plug in directly, you got infinity over infinity here. When you plug in directly, you will get infinity over infinity too. Can you use L'Hopital's rule? Absolutely yes, you can use L'Hopital's rule. But this is easier than L'Hopital's rule, so I didn't use, because sometimes if there is like a square root or some exponent, fractional exponent, it will be easier not to use L'Hopital's rule. But you are always welcome to use L'Hopital's rule if it takes one of the indeterminate form. When you plug in the limit at the beginning, if it takes one of the indeterminate form, then you can free to use the L'Hopital's rule or use this method. Okay, but you cannot use these three rules if the top has fractional exponent or the root, or bottom has fractional exponent or negative exponent or the root. Okay, if both fx and gx must be polynomial to use these rules. Okay, next let's do this problem. 2x over x to the 6 minus 1. So we can use that rule. Why is that? Because the bottom has the fractional exponent, so this is not a polynomial. Okay, what we do, we use that technique, try to factor out the highest exponent term. Okay, so this will be limit x tends to infinity. You are free to use L'Hopital's rule if you want to use that. L'Hopital's rule means find the derivative of the top separately, find the derivative of the bottom separately, and continue doing that. Okay, unless you get one of the nice form. Okay, so keep 2x on the top. Now what I want to do here is I want to factor out x to the 6 inside the parenthesis. If I take x to the 6 inside the parenthesis, what is left is 1 minus 1 over x to the 6. You see that? And outside there is 1/3. this is the product there, so I can distribute this 1/3 to the product there. So it is limit x tends to infinity 2x over x to the 6 times 1/3 in the exponent, right? And then 1 minus 1 over x to the 6 to the 1/3 again, because I'm giving this 1/3 to x to the 6 and that parenthesis. Now how much is that? This is 6 divided by 3, that will be 2, right? And also what I'm doing is I want to plug in the limit here, or I can leave it for now and then I can plug in later. Limit x tends to infinity, so 2x over x squared times 1 minus 1 over x to the 6 to the 1/3. Now let us cancel that x, and then x squared is x times x, right? So you cancel one of those, so what is left is 1 over x. If you plug in the limit, what do you get? If you plug in the limit here, then it will be, let me simplify that first, 2 over x times 1 minus 1 over x to the 6. Let me plug in x tends to infinity here. When you do that, this term will be 0, right? Because 1 over infinity to the 6 will be very big number. You divide 1 by a very big number, this will be 0. Now 1 minus 0 is 1, so 2 over x, that's what it is left, right? Now if you plug in the limit infinity 2 over infinity, this is what you will get, right? This is again 0. So answer to this problem is again 0. But not all of the answers are 0, okay? Some of them can be 0, some of them may not be 0. Let us see this example and then it will be clear. Okay, let me plug in the limit directly. What do you get? Here if you plug in the limit directly, you will get infinity over infinity, right? So you don't plug in the limit directly. You will have to do some more things to do that. Okay, next here, let me plug in the limit directly. What do you get? 5 over infinity, right? This is what you will get. 5 over infinity minus infinity over 3. What do you get? 5 over infinity is 0 minus infinity over 3 is infinity. So basically negative infinity. So you don't get the indeterminate form. So that is the final answer. So the limit does not exist. Because the answer is infinity, limit does not exist. Okay. So this is how we find out the limit at infinity. So it is similar to the what we have done. You just plug in the limit at the beginning, and then if it is one of these indeterminate form, then you try to simplify and then plug in the limit later. Okay, the best approach is try to factor out from the top and factor out from the bottom the highest exponent term from the top and highest exponent of x from the bottom, highest exponent of x from the top, and then cancel out the common part and then plug in the limit on the remaining one. Okay, that's what we do. So to find out the limit at infinity. Okay, so we will do more examples in the next video. Okay guys.